A very warm welcome to the subscribers of the Global Energy Association. This is the continuation of our series of chats with people who've been shortlisted for this year's prize. And until now, we've been in a bit of a vicious circle. Europe, America, America, Europe, Europe, America. Today, we're finally out of that vicious circle and we have China. So I'm joined by Sophia Morgan from the association and Dr. He is joining us from Beijing.
He.
How do you pronounce it? Oh, that's one of those interesting Chinese sounds.
Yeah. Maybe the Chinese meaning is river. It's a very strange surname.
That's a very good surname for a scientist and a researcher. Congratulations. Oh, well, then this is a family thing. Good.
Okay. I'm a family thing. Yeah.
Let me then describe who you are. So, Dr. He, was I right now? Dr. He was nominated for fundamental research and development of advanced electric power transmissions technologies. In simpler terms, because I always try to reinterpret it for our viewers, in simpler terms, Dr. He has made outstanding contribution to the understanding of lightning striking process to transmission line and developed an accurate numerical shielding failure analysis method for lightning striking transmission lines, which, given the framework of our association, reminds us of the fact that the first laureate of the prize in 2003 was Gennady Mesets. Sophia, who was Gennady Mesets? Why was he awarded the prize? You as a veteran of the association.
Yeah, Gennady Mesets was one of the first three laureates the first year of the Global Energy Prize existing, and he is usually referred here in Russia as a man who tamed the lightning. So he saw what was happening during the spark discharge, and he was able to create this powerful artificial lightning. Right now, his research helps to check the safety of the modern aircraft, and that is why I would like to ask Dr. He, what was your way to cope with the lightning?
Yeah. So electric power transmission is a very important sector of global energy delivery. So long-distance transmission of electric power is one of the major challenges of the electric age. So lightning seriously threatens safe of electric power transmission lines. So 80 to 70% of the total electric power signal fails are caused by lightning. So I have done some contributions to lightning protection technology. So I have done a lot of experiments to study the mechanism, how the lightning strikes the transmission line. So we get the physical process, and then we simulate the actual we conduct a high voltage experiment to simulate upward leaders from transmission lines and obtain the key parameters of upward leaders. All these fundamental works are greatly improved our insight on the lightning striking process to transmission lines. So, and then based on our experimental observations, we developed an accurate lightning shielding failure analysis method for transmission lines, especially for UHV transmission lines. So such a method is more accurate to simulate the real process of lightning stroke and provide accurate statistical probability of lightning shielding failure of transmission lines. So which is a fundamental help to optimally design the overhead ground wires to eliminate lightning shielding failure accidents, and is an effective tool in simulating the lightning striking process to high torques, such as wind turbines. Yeah.
Dr. He, how do you simulate the lightning?
Yeah.
What do you
do? So I just say the first we get to know the physical process of lightning striking transmission lines, and then we put the lightning ground, transmission line, and everything together. Then we based on the electromagnetic field, and then we use the numerical analysis method to simulation the lightning striking process. In the past, we use simple formulas to simulate lightning strike the transmission line. We use a formula form, but now we can simulate the lightning striking process. We can see the lightning striking the transmission lines. So this is completely different from the old method. So, yeah.
Does it also rain in your laboratory during the lightning?
Yeah. So cloud, everything. We can consider everything together. So this method has been suggested by Seeger for technical brochures. And has been widely used in the world.
Thank you for your good, very good.
It's very old. This is maybe this is my work many years ago.
Tell me something. We've heard that it's lightning, which is the cause of major power grid trip-outs in China. What are the other common causes of blackouts?
Maybe pollution. Air pollution,
but other than the pollution, it's the lightning, because of course you're in the south. Sophia, anything on your mind?
Oh, yes. Insulation materials that you created, they can improve the qualities of the high voltage underground energy cables. This solution, I mean, burying power lines under the ground, is it better than hanging it above our heads?
So I think because transmission line can be easily influenced by lightning or with gas pollution, so it's a very good method to transmission power. The best way is use the power cable, and power cable is built inside the soil. So then power transmission cannot be influenced by the lightning or influenced by the pollution. So in recent years, development of HVDC power cable is a key to environment-friendly, long-distance and large-capacity electric power transmission. So we innovated the electric insulation material system for power cables. The insulation aging and break damages caused by lightning and other traction voltage and working voltage are the bottleneck restricting the development of electric power transmission by cables. So we have solved the key fundamental problem of large capacity HVDC cable, which provided the key support to construct a large capacity underground energy channel in the near future. So first, we developed the heat shrinkable properly cable insulation materials to solve the problem that the traditional XLPE insulation cannot be recycled, and the space charge accumulation is serious under HVDC. So the insulation resistivity of the new materials have been increased by an order of magnitude, and the operation temperature has been increased from 70 to nearly 110 degrees Celsius. So the cable transmission capacity will be increased about 40%. So I think the most important innovation work is we realize the self-healing of electrical tree damage and completely recover the recovery of insulation performance of thermoplastic cable insulation for the first time in the world. So the irreversible process of electric tree aging has therefore been reversed. So which can greatly improve the electric power cable life, and the self-healing insulation materials will bring brand new smart power cable technology. So I think we developed a very complete new materials for the power cable. So
very interesting. Very helpful, very useful. May I declassify a little secret for you? If you look at the window where Sophia is, you will see little pillows there on the window. That's a place for the privileged people. So if you ever visit Russia, maybe you will have a chance to sit down there. But other than that, what makes you run for the Global Energy Prize? You already are the recipients of numerous national awards. Why do you want our prize?
Pardon?
Why do you want to receive the Global Energy Prize? You've got so many prizes already.
I think I think now the energy is the very, very important issue in the world. Yeah. So, and you show I had received a lot of awards from the IEEE, but IEEE is an organization, but the global energy price is completely different. So this is I think it's a bigger price in the energy field. So, as you know, the power traditional power industry is a very important sector of the energy. So I think if I have a chance to get the global energy prize, I think first it's a great honor to me. And on the other hand, I think I will be the first Chinese to receive this award. So on the other hand,
as I said, if it's circle, absolutely.
Yeah. So maybe,
thank you, sir, because otherwise you will be flattering us endlessly and will be feeling ashamed.
Yeah. So even we see the shipping of this award, so make this award very, very famous in China. Presently, a lot of Chinese, some famous scientists, they don't know this award. Yeah.
Good. Thank you so much indeed, sir.